You know, have you ever actually wondered how a company that started out just making graphics chips for video games somehow transformed into a $4 trillion engine? I mean, literally powering the entire artificial intelligence revolution? Welcome to This Explainer. I'm incredibly excited to guide you through this today, because the story of NVIDIA isn't just about silicon and circuitry. It's about a fundamental rewiring of how computing actually works and how it's completely reshaping our future along the way. We're going to look closely at the architecture of the AI era, pulling insights directly from NVIDIA's latest keynotes, expert tech reviews, and financial analyses. Okay, let's dive into this. Here's our roadmap for today. First, we'll look at the AI revolution engine. Then, scaling up with AI factories. After that, scaling down to personal AI. Then we'll cover physical AI and robotics, and finally, the trillion-dollar question. We are going to cover everything here, from massive stadium-sized AI factories right down to personal laptops that are just 14 millimeters thick, and, of course, the actual realities of the stock market. Let's get to it. Section 1. The AI Revolution Engine. Generating tokens. So, to really grasp NVIDIA's dominance, we first have to understand a massive fundamental shift in computer science. See, for decades, computing was all about retrieval. It was basically like a giant, highly trained soldier working serially to execute one complex task perfectly just to go fetch a file. But, well, that era is ending. We've shifted to generating answers, one token at a time. And to do this, you don't need one giant soldier. You need a GPU. As a recent CNBC breakdown perfectly put it, a GPU, which, by the way, NVIDIA pioneered, is like an army of thousands of smaller soldiers working in parallel. When you're trying to calculate the probabilities of millions of words to generate the very next token in a sentence, you absolutely need that parallel army. And this parallel computing paved the way for what NVIDIA CEO Jensen Huang calls Agentic AI. Now, this is a massive, massive leap from the one-shot AI models we were using just a year or two ago. You remember those, right? You asked a question, it instantly blurted out an answer, and honestly, it often hallucinated or just got the complex logic totally wrong. But Agentic AI, it actually perceives its context. It reasons through problems step by step. It can plan, it can take action, and it can even use tools like a web browser to do research before getting back to you. It's a real game changer. But here's the catch, and it's a big one, because this new agentic AI uses chain-of-thought reasoning to basically talk to itself and test different paths before presenting an answer to you. It generates a massive sequence of internal tokens. Generating all those internal steps means it requires easily 100 times more compute power than those previous models. 100 times. So the immediate question becomes, how on earth do you physically build the computing infrastructure to handle a 100x increase in demand? That brings us to Section 2. Scaling up AI factories, building for the macro scale. To meet this insane 100x demand, NVIDIA realized pretty quickly they couldn't just build slightly faster chips. They had to build entirely new classes of supercomputers. Look at this relentless one-year product roadmap. This isn't your standard run-of-the-mill tech upgrade cycle. It's a staggering jump in scale-up performance. We start with the Hopper architecture, which honestly revolutionized AI as we know it. But in just 1 year, the new Blackwell architecture offers 68 times the scale-up computing performance of Hopper. 68 times! And they aren't stopping there. By the second half of next year, we're looking at the Vera Rubin architecture, and by 2027, the Rubin Ultra, which is aiming for an unimaginable 15 exaflops of power. But keep in mind, these aren't just chips you slot into a standard motherboard. We're talking about entire 1 gigawatt AI factories. To put that physical scale into perspective, these data centers are so dense, they pack 5 billion components and 200,000 miles of fiber optic cables. That is almost the distance from the Earth to the Moon. And because these racks are completely liquid-cooled and just so incredibly complex, NVIDIA actually has to build a perfect digital twin of the factory inside their Omniverse simulation software just to plan the physical construction without making catastrophic errors. And this brilliantly illustrates the core thesis from NVIDIA's CEO, Jensen Huang. He said, the computer has become a generator of tokens, not a retrieval of files. These massive, completely liquid-cooled stadium-sized buildings, they aren't IT storage centers holding your old emails anymore. They are literal manufacturing plants, and their only product is artificial intelligence tokens. Let's pivot now to Section 3, Scaling Down, Personal AI, the Microscale. So, we've seen the stadium-sized factories, but what does this all mean for the microscale? Enter the NVIDIA RTX Spark. As recently highlighted in a super enthusiastic review by Linus Tech Tips, this is a total seismic shift in personal computing. NVIDIA has somehow packed a custom Blackwell GPU alongside 20 ARM CPU cores onto a single chip. It boasts up to 128 gigabytes of unified memory, built on a hyper-efficient 3-nanometer process with MediaTek. And the crazy part? This single package chip brings data center level AI horsepower right into ultra thin laptops. We're talking as slim as 14 millimeters while still promising all day battery life. It's essentially taking the entire AI revolution and just dropping it right into your backpack. Now, the crucial point is how this actually changes your daily workflow. Just imagine this sequence. Using NVIDIA's OpenShell software, your computer dynamically decides if a user query needs the cloud or if it can be done locally. Because you have the RTX Spark, massive agentic AI tasks can run natively right on your laptop. Your local AI agent can reason through complex workflows, directly collaborating with heavy Windows apps like Adobe Premiere. And the absolute biggest takeaway here? Privacy. You get a wildly capable AI collaborator analyzing your local files without ever having to send your sensitive, private data up to some cloud server. Let's move to and see how this builds into Section 4, Physical AI and Robotics, Navigating the Real World. AI's next great leap is finally stepping off the digital screen and into the physical world. But as you can imagine, training a robot in the real world is incredibly slow, dangerous, and very expensive. So NVIDIA created this fascinating continuous digital training loop. First, their Omniverse and Cosmos platforms generate infinite, hyper-realistic synthetic training environments. Then, inside the Isaac Lab, the robot uses reinforcement learning to practice its skills millions of times. Finally, the newly announced Newton physics engine provides real-time, verifiable physical feedback, giving it true friction and gravity. So these robots are practicing and failing in super real-time simulation, completely mastering their environment before they ever even take a single physical step in the real world. And the brain powering all these robots? It's called GR00T N1. It's an open-sourced, generalist foundation model designed specifically for humanoid robots. What makes GR00T N1 so incredibly special is its dual system architecture, which is actually kind of inspired by human psychology. It features a thinking slow system to perceive environments and reason through complex instructions, and a thinking fast system that translates those complex plans into incredibly precise, continuous physical actions. It literally translates reasoning directly into movement. Section 5, The Trillion-Dollar Question, Market Realities. A technological revolution of this scale requires funding on a level the world has rarely ever seen. As reported by Bloomberg analysts, the major tech giants, companies like Alphabet, Meta, and Microsoft, are essentially giving their engineering teams a blank check to build this infrastructure. Each of these hyperscalers is seeing roughly 70% year-over-year growth in their capital expenditure. To put that massive scale into perspective, total AI infrastructure spending is expected to hit somewhere between $725 billion and $1 trillion by 2026. These companies are racing to buy up NVIDIA's hardware literally as fast as it can be produced. Now, what's really interesting about this slide is the financial paradox it reveals. If you look at the forward price-to-earnings ratio, which is how the market values a stock based on its expected future profits, NVIDIA is trading at around 22 times forward earnings. Meanwhile, a legacy company like Coca-Cola is trading at about 26 times. Think about that counterintuitive reality for a second. A tech company growing its revenue at 85% year over year is currently trading at a lower forward multiple than a soda company growing at just 4 to 5%. So how exactly is this possible? Well, it all comes down to the E in that P/E equation, earnings. Right now, Wall Street is caught in a massive tension. On one hand, NVIDIA is generating parabolic earnings with truly massive profit margins. But on the other side, there's a very real fear among some investors that this hyperscaler capital expenditure might just be a cyclical hardware boom. The underlying concern is that eventually companies like Microsoft and Meta might hit a plateau. They might pause to digest all the processing capacity they've already bought and basically stop writing those blank checks. So the market is actively weighing this explosive growth against the historical reality that semiconductors have traditionally always been a cyclical business. Which leaves us with this final provocative thought for our explainer today. Are we witnessing the foundational dawn of a sustainable, multi-trillion-dollar AI infrastructure that will indefinitely power our digital and physical lives? Or are we simply staring at the peak of a massive but ultimately cyclical hardware boom? The pieces of this monumental tech puzzle are still falling into place, and I highly encourage you to keep tracking how this all plays out. Thank you so much for joining me to explore the mechanics behind this revolution, and I'll see you in the next explainer.